Yeah, we are almost there. Almost there. Hi guys, welcome to the second episode of this series in which we are converting this beautiful 1976 TR6 from carburetors, Zenith-Stromberg carburetors, to throttle body injection system, as known as the Patton Machine. This is a throttle body system that Rick Patton invented, and with the help of some adapters that he made, he is able to convert the Zenith-Stromberg carburetors essentially into throttle bodies. And he also has adapters available for SU carburetors and side draft Hitachi carburetors as well. So not only TR6 can be converted, but also TR4, TR3, TVRs, Jaguars, and everything that uses these carburetors can be converted. 4-cylinder, 6-cylinder, I believe 12-cylinder, etc. So in the first episode of this series, we unboxed the whole system. We took out all the components that come with the kit, and we explained what they are, what they do, what is their role in the system, and how they communicate with everything else. So that, I hope, helped for some people who were like me 4 months ago and didn't know anything about injection system. Like 4 months ago, I only heard of MAP sensors and O2 sensors and all that, but what were they doing? I had no idea. I had to work on a car that had the Patton Machine installed already, and I had to learn on the go. So I realized that it wasn't that complicated, and that's why I wanted to explain what I learned to everybody who is interested in installing one of these systems in their car, or they just want to have the common knowledge. So if you haven't seen the first episode and you are not familiar with injection systems, you better go and watch that now before you watch the rest of this episode, because here you need to have the base that we covered in the first episode. In case you've seen the first episode, well, welcome to the second one, and we're going to continue with installing more components into the car. And I think the first one that we need to install is the wiring harness, because we want to see if it's going to reach all these spots where we want to put those components. In the previous episode, we connected everything and we determined what end does what. Most of it is marked anyways from Rick Patton. So we figured that we have to drill a big hole somewhere. So without further ado, let's get crack-a-lacking with that. Alright, so my idea is to put the ECU under here. So we have this flat spot. Let me see if I can show it to you. Right here. I think that's not a bad position for it. And that's the other side of this, right? So the glove box is further in. This here underneath is totally empty. So I think it's a good spot. I removed this plug from here. I was thinking to make this hole bigger and run the wires from there, but I'm gonna plug it, don't worry. But I think the most sense makes to make the hole here, and the wires can come out of here. Now, with that said, look at how many wires need to go through, or maybe the grommet can be right here, so it can be smaller. And that was my idea. Initially, I thought maybe I should do that. I didn't have a big grommet that's like about an inch. So I went and out of Delrin, I made this grommet. So my idea was to put it on like it is split, so I can put it on there and then push it on. You see, it has a groove here, so I can just push it in and then it can click, and it was going to be perfect. However, I realized that this hole where the grommet is going to go needs to be big enough for this connector to go through. This is the biggest one. This one is also pretty big, but it's smaller. But this one, we have no way of passing through a smaller hole. And on the other side, if we want to go the other direction, these ones are even bigger. So, and relays and stuff, so we can't do that. We need to pass this through the hole. So we need a bigger hole there. This means we need a bigger grommet. So that's the next size I have. This is for a steering shaft for TR6. But this is huge. I don't want to make such a big hole for only these wires. So I went and I made my custom one. I had a piece of rubber that I put on my lathe like this, and I was able to machine it a little bit. It makes a little bit of a rubbery dust here that I'm gonna have to vacuum now, but I was able to make my own grommet. This groove here is with diameter 1.5 inches, so we have to make 1.5 inch hole there. We have no way around it for this to pass through. This is 1.5, and then we're gonna put this grommet, but I'm thinking it's gonna be right here because that's bigger than here. So right here, that's the part that we're gonna keep inside the grommet. Okay. Alright, so I'm making some progress here, but it is boring, so I'm just gonna show you the results, not how I did it, because it's stupid. I mean, we have to go through that, but it's just boring. So you remember these little clips? They go like this. I only put two, so now I'm putting the other two together. And then I made these two rails that I'm gonna mount underneath on the ceiling inside. I already drilled the holes there, and then I have these slots. So we're gonna push this. What just happened here? Okay, I didn't consider that. Apparently the distance here is different than the distance here. So I'm gonna have to open these slots a little. Oh well, I made this one much bigger than this one, which essentially moved the whole entire thing a little bit. So I had to make this hole bigger because I already had these holes drilled in the car. And for holding them down there, I'm gonna use these screws because they're gonna be exposed in the engine bay. And I'm gonna put some rubber washers here, so when it is compressed, any water that goes on that deck is not gonna go inside, because that's gonna be right under, right? Alright, so this is how it's mounted. I don't know if you understand what's going on there. I mean, it's hard to film underneath there, but I'm planning to just roll these wires like this and zip tie them somehow up there. Right here on the side are also the relays, and guess how I mounted them there? On the same screws that hold the ECU there. I hope I don't need to take it down anytime soon. Well, it's tricky, but it's doable. It's 4 screws and they don't need to come off, they can just be loosened. So once this is hooked up there, it's gonna be nice and clean here. We will see how we're gonna run this. One needs to be hooked up to the green circuit, maybe to the reverse light connection over there, because that is live with ignition. These two are for the check engine light. That is gonna be right here, so short. And the only one that's a little bit of a pain in the butt is this one, which is for the fuel pump. So we're gonna have to somehow run it this way. This is the plug for the ALDL cable that's gonna be mounted on this rail here. You know, there's a rail right here under the glove box, so that's where I'm gonna mount it. And this other one, this is the AC wire that we said we're not gonna use. So from the engine bay, I fished it through a little hole back inside so I can roll it and zip tie it up there. I don't want to cut it, so I just pushed it through this little hole here. I'm gonna have to put a grommet on the hole, but yeah, that's how it goes. I also mounted already the map sensor and the IAC valve right here, and I plugged them in. I'm gonna have to do some wire management at the end. We'll see how we're gonna group them and secure them so they are not dangling like that. This is the O2 sensor, so you see it comes out here. Again, it's just dangling here, but we're gonna figure out a good way to mount it. These are pain in the butt, all these wires here. These are the two injectors, the temperature sensor, and one more, which is the throttle position sensor. So this is the throttle position sensor. So these we're gonna have to figure out how to route them as well, because they are all here on top of the carburetor. So obviously they somehow need to go over. I just want everything to be nice and neat, but sometimes it's not really possible. And there's two wires that go in that direction here, like right in front of the battery. One is the engine ground, so we're gonna figure out where to hook this up. It doesn't need to go to this ground or earth trap. It can be anywhere on the engine, so I'm thinking maybe here on the blanking plate, when we remove the fuel pump, on the stud for the blanking plate we can put also this wire. And the last one is for the electronic ignition and the coil. So there's more to it, so we're gonna have to also figure out how to route it, but it's pretty good. I think it's not too bad. So I'm gonna continue with these now. I'm gonna have to remove now the choke cable and install the check engine light there. And I'm gonna hook these up wherever they have to be hooked up. I'm gonna fish the fuel pump also and hook up the fuel pump underneath, so we know that everything under the car is finished as wiring and everything inside the cockpit, and then it's gonna be a matter only of hooking up these. And then we're gonna start with the hardware. I mean, the throttle body adapters, the electronic ignition needs to be installed, the distributor needs to be converted, and some vacuum lines need to be run here to the map sensor and the IAC valve, and basically that's it. So this is gonna fit inside there, but we have a flat here on top that doesn't allow the choke cable to turn. Well, here we don't have that flat, so we're gonna have to file this a little bit. That's how long it takes. Now it fits. Click. There you go. All right, so all the wiring here is cleaned up. I can actually now put the speaker and the cover here to complete, but you see this is the check engine light wiring is here. The ignition wire is this pink one coming from here and going back and hooking up to the green wire for the reverse light. So this green circuit is always live with the ignition. And the last wire, the fuel pump wire, I fished through here, going down, and together with all the wires that go to the amplifiers and stuff, and it is now sticking up here. So now I'm gonna solder extension because it's short, and then we're gonna fish it through there, and we're gonna push it down through one of these grommets over there. I don't know if you see them, but we put grommets there for the return line and for the vent for the gas tank. All right, so I extended the red wire from that end, comes down here, and I also hooked up a black wire. Actually it's black with white because I ran out of black, but it's clear that this is the ground, and I hooked it up here because I'd rather have the ground for the fuel pump hooked up somewhere inside where it's not going to corrode. And I just wanted to show you this sleeve that I've been using for wiring wherever I could. I love it. It's a woven sleeve, so it can become bigger when you push it in. It becomes big size, so it can go over, and then when you pull it, it becomes the size of the wiring, and it's nice and tight. So I pushed part of it here, and I'm just gonna leave the ends exposed here for where that's gonna hook up to the pump. And yes, I already determined the length. I pushed the red wire through, I ran it to the pump, and then I cut it, and then I pulled it back out, and now I'm putting it back together with the black one. I put shrink tubing here in advance, so that's where it's gonna be. And now I'm gonna push this through the grommet for one of the fuel lines, and I can put this panel back in. Alright, so this is where the other end comes now, and here on the fuel pump we have large screw is ground, small screw is positive, and this is the fuel flow. And here you see the large is at the bottom, the small is at the top. So this is our positive, this is our negative. It also says it here on the actual pump somewhere, but it's hard to see now. I could see it before. Yeah, here you see this is negative, that up there is positive. So anyway, and I'm also gonna use these boots that came with the kit. All right, so it is installed here, the wiring nice and clean. The boots are on, so it is protected against the weather. Now, somebody commented in one of my previous videos, rightfully though, that the fuel filter is pretty close here to the exhaust. I didn't expect that. I mean, when I made this decision here about the fuel pump and the filter, I didn't consider that this car has dual exhaust and one of the pipes goes this way. Normally they go this way, right? And they go into the muffler, which is over there, and then it goes that way. So now, having this in mind, I think it was going to be much smarter if I actually put the pump right here. Look how much space there is here. I should have done that. For now, I'm going to leave it like that. I'm not worried about catching fire or anything because there shouldn't be fuel on the outside here, right? The problem is the heat, the fuel inside the filter might evaporate or start percolating, or I don't know. So we'll see. We're going to leave it like this for now. And when we start the car, we're going to come here with the thermal camera and we're going to start monitoring and see how hot the exhaust is here and how hot the filter and the pump are going to become. So we're going to see that. And in the worst case scenario, we're going to have to just run a line from up there. Oh, by the way, this is where my valve is and it is closed for now. We're going to fill up the tank with fuel and then we're going to open it and check for leaks here and all that. But in the worst case scenario, we might take a line from here to here, like a flex line, and then take the pump out and the filter and shorten this line, then use flex line from here to the filter, then the pump, and then back into this line. There are a few oil drips, like one is from here, from the transmission. Unfortunately, it's leaking from the front somewhere, making few spots on the ground. And there's another one up here that drips down there. It's not very big, but it is annoying that freshly rebuilt stuff still gets drips. You see, this is where there's no gasket on the differential. And when I overhauled this differential, I put ultra black here, but why is it still leaking? Oh, anyway, we're gonna tighten this a little bit. Back to our fuel injection. So we're done under the car, and I'm gonna go start working in the engine bay now. All right, so at the engine bay, I think I didn't show you this before. The wire that needs to be hooked up to the battery is also here. So I just shortened it. It was long. I left this because I will try to hook it up all the way to here. And it came with this shrink wrap. I think this is one of these shrink wraps that come with solder, and you just have to heat it a lot, and the solder is gonna go and solder that part. So you just have to twist it and then heat this up, but I'm not really sure. But I soldered it already, so let's try and see what's gonna happen with the heat now. I think that actually works. I think that actually melted the solder. Is it some low temperature solder? I don't know. Okay, so now we can hook this up here to the battery, but before that, I'm gonna pull the fuse out. We are way too early for hooking up power to the unit, to the ECU. So it's a 30 amp fuse. I'm gonna put it in the glove box and we're gonna install it later. Remind me where it is when I ask you where I put it. And these are also Tom's amplifiers, and these are their fuses here. Now it has a red, a black, and a blue one. Okay, and here the fuse is accessible still. Okay, I'm gonna leave this for now because we don't have the injectors installed yet, and the TPS sensor, we're gonna do that later. And let's go on the other side and see what's with the wiring there. Well, on this side we only have the coil and the electronic ignition, and we have this wire for the ground that we said we're gonna mount on the blanking plate for the fuel pump. So you know what, let's start with that first. Let's remove this pump, we don't need it anymore. We're not starting this car anymore until we have the whole TBI system installed. So I'm removing this pipe so we can get rid of this as well. And yeah, you're right, I'm forgetting something on the other side. We have that wire that goes to the starter motor that needs to be hooked up to the trigger of the solenoid. So we're gonna have to go back there, but now I set you up here already, so I'm gonna remove this, and later we're gonna go back there for that wire. Yeah, you're actually right. I'm removing the input of this fuel pump now, but we still have fuel in the system, and especially in the float bowls of the carburetors. And these are not gonna be used anymore, so that fuel will have no other chance but to evaporate, and we don't want that. Well, I'm assuming it's gonna be sucked the first time we start the car. There's not gonna be a needle there anymore, so I'm assuming it's gonna be sucked from the vacuum. But you know what, I wanna start the car and run it out of gas. I don't want to start it with fuel in the carburetors, I mean in the float bowls. At least the biggest part of it we can burn. So I already removed the chokes though, so it's gonna be tricky to start it now. It hasn't been started in 2 days, but we'll figure it out. So I'm gonna need to hold the chokes manually here. So I need to be here and somebody needs to crank, but there's nobody to crank. So what if we unplug that wire from the starter, the trigger wire, and plug in this wire instead, and then touch this to power. Now we need to hook the ground up. It's in neutral, so I can crank it. Let's see. There you go. Now we have to turn the ignition on. Now I need a third handle. Oh, actually, the chokes stay. How come they stay where I put them? Oh, the coil is unplugged as well because I had the ignition on the other day for a longer time and I unplugged the coil. Okay. There you go. Oh, my pipes are in the garage. I need to push them out the door. Did it? Yep, almost there. I think one of the carbs still has gas. Okay, so that's it. Turn the ignition off quickly. So now in theory we're out of gas. So let me remove this line now and all the fuel supply from there. That was the last run of the car with carburetors. Next start is going to be with injection system. Okay, I removed the fuel line from here, but because the distributor is now in my way and we're going to be converting this a little bit later to electronic ignition, I mean different electronic ignition, so I'm going to remove it now so it is out of the way, and after we put the blanking plate there we might come and start dealing with the distributor and the coil. So there's two ways to remove it. One is to loosen the bracket from the distributor and take out the distributor, leaving the bracket there, but the easier way is to remove this screw from the back, and that holds the bracket to the block. So now the bracket is going to come out together with the distributor. So the screw is out. I have to unplug the wires from the electronic ignition that go to the coil, and now we can take the distributor out. We also disconnected the tachometer cable from here and the vacuum line. So you can see here now the pedestal is still there, so there's no way that we mess up with the gear there. Some people are afraid to remove the distributor because they're afraid that they're gonna lose the orientation of the distributor drive gear. No, it is, the distributor drive gear is meshed with the camshaft there and it's not moving, so don't worry. And then because this slot here is offset a little bit from the center on the distributor, there's only one way that it can engage with that drive gear, so don't worry, you're not gonna lose anything. Okay, the distributor is out and I have more access to the pump now. I'm gonna remove it. I'm gonna put the blanking plate, and then we're gonna come back to the distributor or the coil. We will see what we're gonna do first because there's some stuff that we need to install here at the coil as well. So the fuel pump is out, and before I install the blanking plate, I just wanted to show it to you. It comes with the kit, with the throttle body injection system and a gasket. So it is basically with the shape of the back of the pump, with the shape of the fuel pump, and it just goes and closes that hole because we don't need it anymore. It also has this port here, which we don't need for the injection system, but this port is in case you have an oil separator, you can use this for your return line. Anyway, so I'm gonna put gasket maker here, Permatex Forma gasket, and I'm gonna put it on, and then we're gonna continue with probably the coil actually. Okay, so the plate is installed, the wire for the engine earth is installed. So the next thing that we want to install, as you can see, I removed the coil already, which goes there with two bolts. So here we can mount this electronic ignition module. Again, it's by GM, and That's where this plugs in, right here. And there's also this small wire that plugs into the other one, and these two ends go to the coil. And here underneath there's two terminals, one says P, one says N. These are for the module from the distributor that we're gonna install a little bit later. So this comes here, and then our coil goes the same way, and the bolts are holding the two at the same time. Okay, so it is installed nice and solid there, and now we can plug it in. So like we said, the big thing comes here, the smaller thing comes here, and I already put terminals at the end of these wires. So it says the white one is negative, the red one is positive. So in this case we have different terminals here, so I put, for the negative of the coil, I put a ring terminal, and for the positive I put a spade terminal. And now here on this side we can still plug in our power to the coil from the original harness. However, as you can see here, we have two wires. Why is that? Well, that's because we have a ballasted system here, and ballasted system used two wires. One is ballasted wire, one is bypass wire. The early cars had only one wire. They also used different coils. So now things become complicated. What kind of a coil can we use here, and what do we do if we have one wire, and what do we do if we have two wires? That's a very valid question. There are cars with ballasted systems and cars with non-ballasted systems. So the coils, as we know, are different. We have ballasted coils or non-ballasted coils. We have 1.5 ohm coils, we have 3 ohm coils. We have 12 volt coils, we have 6 volt coils. How many coils are out there? Oh my God. Well, it's only 2 coils, guys. We just use 3 different names for the same thing. So ballasted, 6 volts, and 1.5 ohm coil is the same thing. The non-ballasted coils are 12 volt, 3 ohm. So that's the 2 types of coils that we have. Just people call them different names. So what kind of a coil can we use? Any of these. We can use ballasted or non-ballasted coil, 1.5 or 3 ohm, doesn't really matter, because the module that we just installed is current limiting. This means that somehow it senses the output of the coil and it regulates the voltage, I guess, or somehow it regulates the current of the coil, the output current. We can use any of that as long as we only use the bypass wire that feeds the coil, if we have a ballasted system. If you don't know what that means, then we have to make a step back and not to self, watch your steps when you make a step back. We need to make a step back and explain how a ballasted system works in order to explain how to use the bypass wire only and not the ballasted wire. So let's go to the computer and show you the schematic. Alright, so this is a schematic for 1972 TR6, but this part with the ignition coil is the same for all the non-ballasted systems, which are up to 73, I believe. Halfway 73, they introduced the ballast. So let's first show how the non-ballasted system works. So we have power to the ignition switch. When we turn the ignition switch on, we have power coming to the positive of the coil right here, 12 volts permanent. On the other side of the coil we have the negative that goes to the distributor, and it gets cut on and off at certain times. We don't need to go that deep. The coil in the earlier cars, the non-ballasted systems, like we said, is 3 ohms. So without explaining in way too many details how the ignition coil works, we are only interested in the result, and the result is that with 12 volts on the positive of the coil and 3 ohm resistance of the coil produces just enough voltage to fire a nice good spark in the spark plug. And that very roughly is about 20,000 volts or 20 kV. Let's just go with kV for shorter. 20 kV is 20 kilovolts. So that's what we know. 12 volts, 3 ohm, 20 kV. So that's perfectly good when we have good voltage coming to the coil. However, there's this guy called Ohm, and he came up with this law. I don't know why he made it, but it is a really bad law. You know the Ohm's law? It is, if something can go bad, it is definitely gonna go bad. Or that was Murphy? Well, okay, whatever. It's the same thing. Ohm said, if you reduce the voltage and keep the resistance the same, then you're gonna have much lower output there for the spark plug. So if your battery is low and you don't send 12 volt to the coil, you send 11 volt or 10 volt in the winter. Imagine these cars were winter drivers as well. So in the winter you have a low battery because of the cold, then you start cranking the car, and as you're cranking it, the voltage goes lower and lower if the car doesn't start immediately, and now all of a sudden you're sending 10 volts instead of 12 volts to the coil. Now the resistance inside the coil is the same, still 3 ohms, but because of Ohm and his stupid law, we are now getting only 15 kV or 10 kV or even 7 kV. It just continues dropping the more the battery goes flat. So that becomes a problem in the winter when we have a lower battery. So what can we do about that? Well, according to Ohm's law as well, we can lower the resistance, because if we lower the voltage but we also lower the resistance, we're still going to produce higher output, higher kV at the end. So why don't we do that? Why don't we use 1.5 ohm coil? And that's gonna double the amount of kV at the end. So with 12 volts and half the resistance, now we're gonna make 40 kV instead of 20, which is more than enough for the car to start. It's gonna be a beautiful spark. And even if the battery voltage drops to 10 or even 9, still the output is not gonna be less than 30 kV or 25, which is still more than the 20 that we need. So that's what the engineers did. They put a 1.5 ohm coil and doubled the amount of kV that was produced. Beautiful. Well, yes, but the coil cannot handle that for a long time. The coil all of a sudden is now doing double the work. It's becoming super hot. And for a short period of time it's fine. But if you continue having the system work with this low resistance there, sooner rather than later, the coil is gonna blow up. And that's why, as soon as the car starts, we can add back the missing 1.5 ohms here, increasing the resistance back to 3 ohms, and now we're gonna have only 20 kV at the end. How can we do that though? Well, easy. That's what the engineers did. In 1973, they introduced the ballasted wire. Now you see we have 2 wires going to the coil instead of just 1. So one wire feeds it while cranking, and the other wire starts feeding it only after the engine starts and we stop cranking it. This pink with white wire is actually our ballast. If you measure between here and here, you have 1.5 ohms. They basically use this wire as extension of the coil. So the coil is 1.5 ohm, and the 1.5 ohms added by this wire, the resistance between here and here is now 3 ohms. So you see where that goes, right? When the car is running normally, from the ignition switch we only have power to the ballast resistor wire, to the ballasted wire. Now we have 3 ohms coil, because this got added to this, and at the output we have 20 kV, everything is fine. Okay, but how do we take advantage of Ohm and his law? We can do that only while cranking the car. Instead of feeding the coil here, we can feed it directly here and essentially bypass this wire. How can we feed it here? Well, this white with yellow wire is connected to the starter motor. So when we're cranking the engine with the key, this white with red wire is live. That's what triggers our solenoid and makes the starter crank. So to the same wire we also connect this white with yellow wire, and while the starter is cranking, this white with yellow wire also becomes live, essentially sending 12 volts directly to the coil, bypassing the ballasted wire. And now we have only 1.5 ohm coil, and now we're producing 40 kV at the end. As soon as the engine starts and we let go of the key and we go to ignition only, not cranking, now this white with red wire is dead, which means that our white with yellow wire is dead, but this white wire is still live and it's still feeding our ballasted resistor wire, adding its resistance to the coil. So now we have 1.5 plus 1.5 ohm, we still have 3 ohm coil, and we start producing 20 kV again. So that's how they solved the problem. So now let's come back to our TBI installation problem and decide what we're going to do here, because obviously we have 2 wires going to the coil. This means that we have ballasted system. This means we have 1.5 ohm coil. And like we said, it's perfectly fine if we use 1.5 ohm coil as long as we bypass the ballasted wire and we feed 12 volts directly to the coil, because our module that we just installed is current limiting and it's going to take care of how much kV we produce there electronically. So we need to bypass this wire. How do we bypass it permanently? We can't connect the white with yellow to the white with red permanently. Let's say we can cut them and twist them together, but no, because the white with red is only live while cranking the engine. So we can't do that. Well, we can go back to how things were earlier. We can connect the coil directly to the fuse here, where the white wire comes from the ignition switch, on the unfused side though, because if we blow a fuse, that's going to kill our engine. So that's how it used to be. Well, we can do the same thing. We can find the white with yellow wire somewhere in the loom close to the fuse, cut it and connect it back here, and essentially we have the same thing as on the early cars, right? That's one option. Another option is just to unplug both and run a new wire from here to here. That's, I think, what we are gonna do here. And that's in case you have a ballasted system with 2 wires. But if you have only 1 wire here and non-ballasted system, then you're perfectly fine to plug your original wire into the coil and you're done. You don't need to make any changes. Okay, so what I just did is I folded back the unused wires here from the coil, and they don't need it anymore, and I didn't want to cut them, so the whole thing is reversible. And I made this wire. I put it in one of my favorite sleeve here. This sleeve, by the way, is coming in different sizes. You can buy it in 1/8, quarter, half-inch, 3/4, etc., etc. I just love it. So we're gonna plug this here, and we're gonna fish this down into the white wire on the fuse box. I know I keep saying that, but I'm gonna say it again. We're gonna do some wire management at the end. We're gonna zip tie them here and there, and we're gonna make sure that everything is nicely organized everywhere, because there's so many wires here. And that's all about the wiring, isn't it? I mean, the only thing that we still need to connect is the part of the electronic ignition that goes to the distributor into the electronic ignition here. And of course all these wires here, but 2 injectors and the throttle position sensor. Oh, we have that wire sticking down there, right? Because the ECU wants to know when we're cranking the engine. Okay, so let's go back to the schematic for a second. Okay, so the ECU wants to know when we're cranking the engine. So we have this wire on the TBI harness that says crank signal. So basically this wire, when it becomes live, it tells the ECU that right now we're cranking the engine, and probably what it does is the exact same thing that we were just discussing. Removes the ballast from the system. I guess that's what it does, like increases the output of the coil in some way. So if you have a newer starter from 73 and later, you definitely have a port on somewhere on the starter where you have to plug this bypass wire, right? Now we eliminated it, so now you can plug your crank signal wire to the same port. If you have an earlier starter that doesn't have this port, or like in this case, we don't have a port because we have a high torque starter. Some high torque starters have this port, but this one doesn't have it. Well, then you can do what I'm gonna do here. So this is what we can do. I made this splitter here for the original crank signal wire that goes to the solenoid. At the starter motor from the solenoid we can unplug the wire that is original to the car, plug this instead, and then the original wire can plug it here. And that restores it to the original setup. So when we turn the key to crank, we have power to this wire that powers up the solenoid clicks and the starter starts to crank. But now this branch is also going to become live, so here is where we can plug in our crank signal wire that tells the ECU when we are cranking the car, like that. And with that, guys, we're done with all the wires. I mean, everything is run in place, 99% of the things are plugged in, the rest are just waiting to be plugged in, but the wires are exactly where they're supposed to be, but we need to install some more components, like we need to convert the distributor to the electronic ignition that comes with the TBI system, with the Patton Machine. And of course we need to convert the carbs to throttle bodies, install the injectors on them, the throttle position sensor as well, and then plug in the last 3 wires that we haven't plugged in yet. So that's going to be the subject of the next video. This one is becoming a little bit too long. We went into a little bit too many details that are not really related to the fuel injection system, but I wanted you to know what you're doing. I mean, not just tell you unplug this wire and plug this one. Instead, I want you to know why you're doing that. So I hope you don't mind a little bit more detail. Anyways, that's gonna be everything for today, guys. Let's finish it here. Thank you guys for watching, commenting, subscribing, sharing, and supporting the channel. About the support, you can read in the description of the video a little bit more. I'm not gonna talk too much about it here, but your support is really, really appreciated. So once again, thank you, and I'll see you in the next one. Bye.